Okay, ladies, this is going to be one of possibly two or three little short video segments covering Chapter 1 PowerPoint. If you have not downloaded the Chapter 1 PowerPoint yet, you need to do so by going to Blackboard, Essential Biology that you've already registered for. Look on the left-hand side, find the PowerPoint presentation button, download Chapter 1. Some of you will think it's really important to print off that PowerPoint presentation. I think that's great. Some of you need to actually handwrite your notes. Fabulous. Please don't just print the whole PowerPoint. It's like 47 pages. Make sure when you hit print that you go down and actually select in the bottom left-hand corner. It's called print, and you get to have a drop-down menu, and you can actually select handouts. So it will put 6 slides on a page. That's pretty critical. Now let's talk about Chapter 1. It's obviously an introduction to biology, so it's going to actually show you a scope and sequence of what we're going to cover for the year. That means it's not going to go in depth into any one of the topics that it talks about. So you may kind of feel like, whoa, Nellie, I don't know what in the world's going on right now. It's kind of like just covering that top layer, okay? So don't panic about that. It won't take us long to cover the information. You've probably already covered it in another class. We will take care of all of that this week. We will have a quest, which is what I like to call a mixture between a quiz and a test. It's pretty fun stuff, fairly easy. We'll have a quest sometime next week. Don't panic about that. You're going to be fine. Now, let's get down to the very first PowerPoint slide. Your authors are really kind of fun because they like to hook you and get you interested in the particular chapter by showing you some really cool fun facts. The first little guy right here you probably recognize from Finding Nemo. He's a pufferfish, and pufferfish, aside from what this is talking about here, have a really cool defense mechanism. They like to make themselves really like 10 or 15 times bigger than they normally are to scare predators away. And typically it works. Look at him. He's huge and he has spikes. I'm really scared. That has nothing to do with what this particular slide's about, however, because this particular slide's talking about how scientists have been able to sequence all sorts of different organisms, humans, pufferfish, chimpanzees, giraffes, elephants, whatever it is. They have actually been able to map the DNA of several different organisms, and they do so in order to find out exactly what sequence of nucleotides these organisms contain in their DNA, so they can find out exactly what proteins these organisms make. And that may not make sense yet, but it certainly will as we continue later on in this book. Now, I love this fact. Scientists have discovered or identified 1.8 million species, and that sounds like a tremendous number, except when you think about the fact that we as humans have only been around for a very short segment of geologic time. There were more species that have probably become extinct before our existence than exist now. And so, I don't know, that's just something to really think about. Now, I really like this little piece of information right here. All living things have several different items in common. One of the things that we have in common is all living things contain cells, no matter what. And all living things actually share a common language. We all share the language of DNA. So that's pretty critical stuff. Now, I really love this part. Mr. Sanders and Mr. Haynes may disagree slightly with me, but I'm going to be honest with you. You are living in the golden age of biology. And by that, I literally mean that you are living in a particular time where the science of biology the scientists in biology are learning something new every single day. It is constant. I mean, physics and chemistry, sure, people are constantly learning a little something about chemistry and physics, but biology, daily, absolutely daily. And so it's even difficult for the textbook companies to make sure that their textbooks are relevant because there's so much new information out there. By the way, your textbook has been able to do something kind of cool to make sure they stay abreast of every situation. They update all their online text information, all their online activities. So don't worry, you're going to be okay. Now, if you think about it, right, how do you know you're living in the golden age of biology? Well, if you're like me, you're in a situation where it doesn't matter what you're doing if you're watching TV in the fall when all the new shows come out. I mean, all your favorite shows, right? All of them, CSI, Bones, House, all those really awesome shows contain a biological component. So as you start this particular year, I want you to think really hard and pay attention to all the different shows that you're watching, all the magazines that you're reading, um, newspapers, maybe even local and national news that you're watching tonight. Pay attention to the amount of biology that's expressed in those. And your job this year as a student is to try to really understand what they're talking about. How cool is that going to be? You don't have to guess anymore. You'll know it. Now, you probably ask yourself this question. I mean, I get it. So it's biology. What exactly is biology, right? I mean, what do you mean by that? Well, biology is the study of life. It's really simple. It's a study of all life. Now, what is life? That's a question I'm going to answer in just a second for you. I want to show you something kind of cool I found many, many years ago. It's called Powers of 10, and it shows you exactly how biology or life is structured on a scale ranging in size from the molecular level all the way up to the global level. Okay, I said molecular to global. Actually, I'm going to take you global all the way down to molecular. Now, this is 10 million light years away, and it is 10 million light years away from our Milky Way galaxy, which is the name of our galaxy. And there are 100 million galaxies out there, and we're just one of them, right? So, 10 million light years away, you're not even going to understand what that means, because a light year is how fast light travels in a year, and it will travel 3 million meters per second. Okay, so we're talking about a really, 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 really long distance. So let's decrease this. Let's keep zooming in. So this is what our Milky Way looks like. It's a spiral galaxy from way, way far away from the Hubble telescope. And then we look on the very, very fringe of this. Do you see how this is just kind of one of those little arms? That's where we live. That's where our solar system is. And you keep zooming through all of these stars, right? All of these stars, which are honestly most of them bigger than our very own sun, which is it in itself a star. You zoom in a little closer, and our sun does appear to be fairly large compared to the other stars around our solar system, and then you have our solar system, right? Now, our solar system does not have these awesome little lines around it. Just doesn't happen in the real world. They're just showing you the orbits of the different planets, and there are 8 planets that revolve around our sun, not Pluto. You know, it got booted out. It's sad times for Pluto, no lie. You zoom in a little closer to our sun, and you're going to find a particular planet that is, let me back up here, the third rock from the sun, so to speak, and that is our Earth. You zoom in a little closer to our Earth, you can see it. That looks very familiar to you, right? That's North America. Zoom in a little closer on North America. You're going to zoom in on the panhandle of Florida. Zoom in a little closer, you're going to be near Tallahassee. When you zoom in a little closer, you're going to get to a particular plant, particular set of trees, a particular tree, a particular leaf. Zoom in on that leaf. You're going to find a vein. Zoom in closer to that vein. You're going to find several different cells on that leaf surface. And on these cells, like this is actually zoomed in on the bottom part of a cell. All of these little guys right here, all of these little guys. Oh, Nellie, go back. Go back. All these little guys right here are stoma. These are little mouths or little openings on the underside of a leaf. These allow for the transfer of oxygen and carbon dioxide. It's so stinking brilliant. Leaves actually breathe. How cool is that, right? So you keep going, right? You zoom in, you get a nucleus. You zoom in, you get chromatin. Chromatin is made up of DNA. That's what DNA looks like, actually. It's spiral. You zoom in, and you're going to get, now this is kind of an animation because we don't know what this looks like in real life. You get all these different atoms. Zoom in on the atom. You get a carbon atom particularly. Zoom in, and this is what the nucleus of the carbon atom looks like. And then you zoom in, and you end up with protons, and then, God forbid, quarks, which very few people really understand. Go talk to Mr. Haynes about that one. So basically what I'm saying about that is that oh wow, our universe is enormous and amazing, and we are just a single speck on that huge beach, right? We are tiny and almost inconsequential. So that's why scientists are constantly looking to see if there might be life on other planets. That concludes part 1. Get ready for part 2.